Hello and welcome to my talk on our study on typological word order correlations using a logistic Brownian motion model. The object of our study were word order traits, as you can see here, for example, for the trait at position and noun order, and how these values are distributed for languages across the globe. The aim of the study was A, to probe for universal correlation patterns in the evolution of such word order traits, and B, to test if cross-family models could capture correlation patterns which we could not find when looking only at single-family models separately. We did so using a logistic Brownian motion model. Here you can see the 8 word order traits we were looking at, always framed as binary traits and always looking at them in pairwise combinations. The evolutionary history we included in the form of phylogenetic family trees, as you can see here, for example, a tree for the Skål language family. The model we were using was a logistic Brownian motion model. Brownian motion is a model that can be used to model the evolution of continuous traits, where the length of the evolutionary process determines the variance of the trait values, and the relatedness of the model species or families and the traits determines the covariance of the values. In our case, we were looking at categorical, specifically binary values, so we extended this model with a binomial distribution to describe the actual trait values, and the actual Brownian motion would be used to describe the logic probabilities for the binomial distribution. This actual Brownian motion model is a multivariate normal distribution where the described traits, or in this case their logic probabilities, are the observed traits for each family. The mean of the normal distribution describes the observed, the hypothetical traits at the root of the family tree and are to be estimated by the model. And the variance-covariance matrix consists of 2 parts combined with the Kronecker product, where one, the matrix C, encodes the shared history of the families, such that families with a longer shared history have a higher covariance. And the second one, the matrix R, encodes the trait behavior, with the diagonal elements describing the evolutionary rate, which determines how much the traits tend to change over time. And the off-diagonal elements describe the actual trait correlation. Now, to test for trait correlation, we compare 2 model variants. First, for each single family separately. The first variant assumes correlation, and there we have both the evolutionary rate and the correlation parameters estimated by the model. And the second variant assumes independence by setting the correlation parameters strictly to 0. We do the same comparison for models across all families to compare universal correlation with universal independence. And here we also compare the universal correlation with a third variant, where we assume lineage-specific correlations only by assigning a separate matrix R to each family in the cross-family model to test if universal correlations are actually more likely than the lineage-specific models. For the results for the single-family models, we found no trait pairs to be correlated consistently across language families, and this observation was consistent for all used evaluation metrics, which were bias factors and two information criteria, WAIC and LUIC. For the cross-family models, the results were less clear. Here the Bayes factor agreed with the single-family model results, which is the lineage-specific correlations were valued much higher than the universal models. And the information criteria, on the other hand, said the exact opposite result by valuing the universal models much higher. So in conclusion, our single-family models and Bayes factors for the universal models speak in favor of lineage-specific correlations only, but the information criteria for the universal models do not agree with this. So what we can say from these studies is that there's no clear evidence in favor of universal trait correlations or to support that cross-family models could actually capture such universal correlations better than the single-family model separately. With this, I finish my talk and thank you for listening.